EC member. Nikita, go ahead.
Okay, thanks, Riddhi. So it's an honor for me to welcome and introduce Professor Ruchi Das, who is a professor at the Department of Mathematics at the University of Delhi. Her research lies in the areas of dynamical systems, topology, and analysis. She obtained her PhD from the MS University of Baroda in 1996, and she was a postdoc fellow at the University of Athens, Greece. Before joining the University of Delhi, she has served the Department of Mathematics at MSU Baroda in various capacities as professor and also as head of the department. She is a member of the editorial board of Asian European Journal of Mathematics. Professor Das has supervised several PhD and MPhil students, and she continues to supervise students at the University of Delhi. And today she is going to talk about a very interesting topic, the butterfly effect, and the title is in front of you. So over to you, Professor Das.
Thank you, Nikita. First of all, I am thankful to organizers of IWM annual conference for giving me this opportunity to talk on this platform where many young female mathematicians are participating, and I am aware of the activities of the IWM and I appreciate all their pains to conduct such kind of activities which is helping the especially female mathematicians to improve their knowledge and broaden this horizon of mathematics knowledge. And where most of my students, they have attended the annual conferences of IWM and other activities, and they were really very happy. And I know that this goes in a long way in the career of the girls students who are motivated from such activities. So I'm very happy to talk on this particular platform where I will get opportunity to interact with young female mathematicians and who are researchers, and many of them are young faculties also in well-known institutes of our country and abroad. So I will come to my talk today, and the title is says that I will be basically talking on transitivity and butterfly effect in dynamical systems. So first of all, what is a dynamical system? This theory attempts to understand and describe the changes that occur in the physical or artificial system. So in a dynamical system, we have a phase space, we have a set of times, and we have a governing rule which says that how the state space is changing with the time. So examples of such systems include solar system, weather, this motion of billiard balls on a billiard table, sugar dissolving in a cup of coffee, traffic jams, how they are formed, stock market, and many other things. In fact, it is said that whatever you see around you, you can see in the form of a dynamical system. And many areas of biology, physics, economics, and applied mathematics, they involve this analysis of dynamical systems based on how their laws are governing their change. So these are some of the examples of dynamical systems. And I will go a little bit to the history of this dynamical system as I could gather from the literature available to us. In fact, it started in 1686 with the publication of Principia, which was laid down by Newton while he was studying the classical mechanics with laws of motions, three body, two body problems like that. And his work, in fact, inspired the work of many mathematicians like Euler, Lagrange, Hamilton, Poincaré, whose work was based on Newton's work. And French mathematician who was by profession engineer, this H. Poincaré, he is considered to be the founder of the modern theory of dynamical system. In fact, his work was great influence to the present state of the subject, and it changed the study from the quantitative to the qualitative study of dynamical systems. He wrote a memoir of 270 pages, which is supposed to be the first textbook in the qualitative theory of dynamical systems. And he wrote this memoir in 1890, and in 1899, he wrote a 3-volume treatise on dynamical systems. So his contribution is great in this particular area, and it was in fact a key step for the development of the modern theory of dynamical systems during the 20th century. And he is Henry Poincaré. As we can see that he died in the year 1912, but if he could have lived more, I think some more uh, work he could have done, which must have developed the theory more as he did earlier in his work. And in fact, this word dynamical system was coined by G.D. Berkoff when he wrote this particular uh, book, which is an American Mathematical Society colloquium, written in 1927 of 305 pages. And in fact, Birkhoff was writing his own work on the subject, which was strongly influenced by the Poincaré's approach to dynamical system. And with this book, he demonstrated that the subject is so beautiful, and not only it was a compilation of his individual results, but he explained many things very nicely, and which later on could get applications in many fields, including the differential equations, mathematical physics, and Moore's theory. In fact, Moore's theory, in differential topology, uh, gives you the idea that how the topology of the differential manifold can be analyzed using the study of the differentiable functions on that particular manifold. So I could say this, that there was a quote in the yearbook of the American Philosophical Society that uh, research of G.D. Birkhoff in dynamics constitutes the middle period of Birkhoff's scientific career and his maturity and greatest power. So I just thought of sharing this quote with all of you. And, my interest in transitivity and butterfly effect originated from the study of chaos. So I was interested that how this theory was developed. So I could gather that this mathematical term chaos was in fact first introduced by Lee and York in 1975 in the paper, which was published in 75 with the title Period 3 Implies Chaos. And in fact, there he talked about the Lee-York chaos. And since then, chaos theory has played a significant role in the study of dynamical system in nonlinear science also. And as we know, the English meaning of chaos we can understand is it's a kind of a state of disorder. So after the introduction of this Lee-York chaos in 1975, various types of chaos have been studied, and most definitions of the chaos are based on one of the following aspects. The one is complex trajectory behavior of points, and this was considered in Lee-York chaos and distributional chaos. He showed that there are uncountably many scrambled set, that is collection of Lee-York pairs, and that gave the introduction of this Lee-York chaos. And the other was butterfly effect, or which is known as sensitive dependence on initial conditions, such as Devani chaos, Oslander chaos, and Lee-York sensitivity. This Devani chaos, I will come later on. The third is based on the growth of different orbits of length n, such as having the positive topological entropy or its invariant. And fourth was a strong recurrence property, such as weakly mixing and weakly mixing sets. I will come to these terms later on again. And it is observed that it is very difficult to give a universal definition of chaos, which covers all the features of complex behaviors of a dynamical system. So first of all, this notion of topological entropy and weak mixing, they were introduced by Adler and Conahem in 1965. That paper was published in Transactions, American Mathematical Society, and by Furstenberg in 1967. And this topological entropy, it was a very useful concept developed in dynamical system. In fact, it gives you the complexity. It's a non-negative extended real number, which gives you the, how the complexity of the dynamical system is measured. And Furstenberg talked about the Furstenberg family, and which was used in studying the chaos theory. After the mathematical term of chaos by Lee York in 75, Devani defined a kind of chaos which is very well studied nowadays, known as Devani chaos. And it was based on this concept of butterfly effect, that is sensitivity, and the definition he used was given by Guggenheimer in 1979. That paper is published in Communication Mathematical Physics. In 1991, Evanek showed that weak mixing implies Lie or chaos. So a lot of study has been done, on the interrelations of different types of chaos. In 2002, it was shown that Devani chaos implies Lie or chaos by proving that a non-periodic transitive system with a periodic point is Lie or chaotic. And Blanchard et al. Proved that positive entropy also implies Lie or chaos. Capturing a common feature of positive entropy and weak mixing, Blanchard and Huang in 2008 defined the notion of weakly mixing sets, and Ismail defined 3 types of distributional chaos, DC1, 2, and 3. And it was known that positive entropy does not imply DC1 chaos, and Ismail conjectured in 1994 that whether positive entropy will imply DC2 chaos. In 2014, Down Warris proved that, in fact, his conjecture was true and positive entropy implies DC2 chaos. In 18, W et al. Have proved that every weakly mixing dynamical system defined on a second countable Bayer-Hausdorff uniform space is chaotic in the sense of both Lie York and Auslander chaos. Related to Devani chaos, there is a very well-known, powerful result proved by this Banks and et al. In 1992. And they showed that on infinite metric space, which doesn't have any isolated point, if we have transitivity and dense set of periodic points, then it will give the butterfly effect, that is sensitivity. And in 94, Wellingtop and et al., they proved that in fact on intervals, transitivity only will give you the chaos. So these are the well-known, very useful results, remarkable results in the theory of dynamical systems. And if I come to, how this concept of transitivity and sensitivity, they became the key ingredients. So let us see how, in fact, we talk of this topological transitivity. So we can think of this, that there is a real physical system where a state is never given or measured exactly, but always there is a certain error. So instead of points, one should study small open subsets of the phase space and see that how these sets, they move in that particular space. In dynamical system, basically, we study orbits of a points. So that gives us the idea that how the system is behaving. So transitivity says that instead of studying the points, one can also study the open subsets, that how they are behaving once you apply the iteration of the functions on that open set. So for example, if I come to the concept of minimality, it says that a system will be minimal. So here XF means that X is a topological space and F is a self-continuous map on X. So we say that this system is minimal if orbit of every point is dense. That means if we take any X in the space, capital X, and then if we take any open set, then some point of the orbit will belong to that open set. That means the orbit will intersect with the open set. So if this is true for every X in the space, then we say that the set is minimal. So instead of studying, the orbit of the points, we say that the system is transitive if for every open set U, it visits every other open set V of X, in the sense that if we start with any non-empty open set U and take another open set V, which is also non-empty, then some iterate of F on U will intersect with V. So if this happens, then we say that the dynamical system is transitive. And intuitively, as I told, that it says that instead of points, how the sets are moving under the iteration of the map. We also say that transitivity is regarded as a reducible condition, because from the definition, we can see that we cannot decompose a transitive dynamical system into two disjoint sets with non-empty interiors, which do not interact under the transformation. Because given any pair of non-empty open sets, we require that there will exist some natural number n such that F and U will intersect with this V. And this particular concept played very important role in the study of several decomposition theorems as well as stability theorems. And for example, if I talk about the decomposition theorems, then we have celebrated Ismail's decomposition theorem, which was published in Differentiable Dynamical System in Bulletin American Mathematical Society in 1961. And Ismail's decomposition theorem says that if we have a differentiable manifold and we have a Anosov diffeomorphism on that manifold, that means it is expansive and has POTP, then its non-wandering point set can be written as union of finitely many closed invariant sets on which that function is transitive. So this was a very celebrated result of Ismail, giving the good applications. And now if I come to the butterfly effect, then it has origin in the work of Edward Lorenz. In fact, he did not give this name sensitivity or sensitive dependence on initial conditions. He called this as butterfly effect. And in fact, he was running some meteorological data to have the idea of the weather prediction. And he observed that, in the small variation gave later on very unpredictable, weather conditions. So this is, he, described it as, you have a butterfly flapping its wings, very far away place and maybe 3 weeks earlier, but after 3 weeks there was a tornado. That means very small change in the initial conditions gives the drastic change in the dynamics of the dynamical system. So this particular observation he called as butterfly effect. And later on this particular notion was given the name as sensitive dependence on initial conditions. And this terminology was first used by D. Rowley in the paper which was published in 1979. And so let me come to this particular example. This is known as Lorenz Attractor, and it is generated by a set of differential equations which models a system of convective flow, that means motion which is induced by heat. And in 1963, Lorenz demonstrated that this system exhibits chaotic behavior when the physical parameters are appropriately chosen. So although this butterfly effect or sensitivity originated with the work of Lorenz, but later on, not only it was used in weather prediction, but it was also used outside this weather science. And let me come to the formally, how do we talk of this system, this particular concept? So if we are given a dynamical system, say X with a self-continuous map F on X, then we say that the system is sensitive if there exists some, delta positive such that whenever we take any point, say X in capital X, and if we take any neighborhood, say U of that X, then we get a Y in that U such that the distance of Fn X, Fn Y is greater than that particular delta. So it says that there should be some constant such that whenever we choose any point and we choose any neighborhood of this point, then there will be a point Y, maybe very close to that particular X, but there will be some natural number such that that iterate of F will make the distance of this Fn X and Fn Y greater than delta. So very small change can give the drastic change in their orbits placing that way. Now the question is, if we define this particular set, that is, we are given an open set U and we are given, say, delta, then we define, say, N F U delta, because it depends upon that F, such that all those N in N, such that there exist 2 points Y and Z, such that distance of Fn Y and Fn Z is greater than delta. That means those N which make their orbit, respective orbit element distance greater than delta, we call as NFUV. Then the sensitivity says that the system will be sensitive. We have some delta positive such that whenever we take any open set U, then this NFU delta is non-empty. So analyzing this definition of sensitivity, Muthatu, asked this question that what is the, I can say the size of this particular NFU delta. So largeness of this set of all N in N which satisfy this particular conditions, this can be thought of as measure of how sensitive the system is. So for example, if that set NFU delta turns out to be very thin with arbitrary large gaps between two consecutive entries, then one can even say that the system is practically non-sensitive. So the question was, what he asked was that, does the sensitivity happens at regular intervals of time, or sensitivity happens for every unit of time after certain stage? So based on this particular questions and based on his definitions, these questions were translated into that, can we say that is the system syndetically sensitive or the system is co-finitely sensitive? In fact, I will come to this definitions later on. What is the meaning of syndetically sensitive and what is the meaning of co-finitely sensitive? In fact, we define, this given a subset A of the set of natural numbers, we say that this set is co-finite if the complement is finite. We say that this set is syndetic if, we can write, if this set is infinite, and suppose we are writing the elements of the set as say A1, A2, A3, so on, with A1 less than A2 less than A3, then there should exist some M such that AN minus 1 is less than that M. So basically it means that there are bounded gaps in the elements of that particular set. So we say that system is syndetically sensitive if that NFU delta turns out to be syndetic. And we say that it is co-finitely sensitive if that particular set turns out to be co-finite. And so he found the relation between these concepts as co-finite sensitive will imply syndetically sensitive will imply sensitive. So co-finitely sensitive is the strongest notion among the three. And he observed that, this reverse implications, they do not hold. So they are not the equivalent notions in this sense. And he gave the examples using the subshift of finite type and this Sturmian sequences on the shift spaces. Using those examples, he showed that sensitive need not imply synthetically sensitive, and synthetically sensitive need not imply cofinite sensitive. And that paper is, yes,
Hello.
yes.
Do you have any question, V. Renuka Devi?
I think it's a
I
mistake.
think it's by mistake.
Go ahead.
Please go.
Ruchi.
Okay. And there are many good examples satisfying these stronger forms of sensitivity, because they imply sensitivity, so they are stronger forms. Many other stronger forms also have been studied, like thick sensitivity, thickly synthetic sensitivity, multi-sensitivity, like that. And similar is the case with the transitivity. There are many stronger forms of transitivity studied in the literature, and interesting results have been found based on his basic questions that whether that particular NFU delta is synthetic set, or it is a cofinite set, or it is a thick set, like that. Now I come to this notion of non-autonomous dynamical systems. In fact, if I go back to the way we talked about the dynamical system, initially we had a topological space and this continuous self-map on X. So we have only one rule, determining that particular system. So we call it autonomous discrete dynamical system. So this is the case when the system is independent of external factors and modulations and does not involve the time varying governing rules. But many real world problems like weather and climate predictions, heartbeat patterns, spread of infection disease, etc., they involve time dependent parameters, modulations, and various other effects. So consequently, many of the well-established methods and results which were obtained for autonomous systems, they were no longer applicable in such kind of situations. And these situations motivated the extension of dynamical systems to namely non-autonomous dynamical systems. And this theory was basically started with this paper of Kolyada and Snoha in 1996. And in fact, they introduced these non-autonomous discrete systems when they were trying to understand better the topological entropy of triangular maps, that is a skew product of dynamical systems. And for that study, they required first to develop the theory of entropy of non-autonomous dynamical systems, because they had to talk about the sequence topological entropy and those kind of things. As I told earlier, this topological entropy is a very useful and interesting notion. In fact, for a long time, it was a problem that how to distinguish the shift maps on shift spaces. For example, if I take the shift map on 2 symbols or take the shift map on 3 symbols, then both of them, they turn out to be, transitive. They have dense set of periodic points. They are sensitive. But it was observed that their dynamical behavior in some sense is different, but how to distinguish them, that was a problem. So in the when this topologically entropy was introduced, it was observed that if we take two dynamical systems which are topologically conjugate, in fact, topological conjugation means suppose we have X, F a dynamical system and Y with say G self map dynamical system. We say that they are topologically conjugate if you have a homeomorphism between X and Y, which makes the diagram commutative. And topologically conjugation is very important notion in dynamical systems, because it turns out to be an equivalence relation in that class. And any property which is preserved under topological conjugacy is called a dynamical property. And if two dynamical systems, they are topologically conjugate, then many of their dynamical properties turns out to be similar. So this particular concept of conjugacy is also very important. And when entropy was introduced, it was observed that if we take two dynamical systems which are topologically conjugate, then their entropy should be same. And it was observed that if we take the this shift maps on different symbols, for example, if I take shift map on 2 symbol or I take shift map on 3 symbol, then their entropies are different. And therefore, this notion helped in distinguishing the shift maps on the different these systems. So in fact, it was proved that if we take the shift map on the shift space generated on, say, 1 to k, where k is a natural number, then the entropy turns out to be log of k. So if we take on, say, 1, 2, then entropy is log 2. If we take generated by 1, 2, 3, then it turns out to be log 3. So their entropy turns out to be different, and therefore these shift maps, the dynamical systems which we are getting on different k, they turned out to be having the different dynamical behavior. So that why this concept of entropy was really nice and helpful in many interesting examples. How do we define this non-autonomous dynamical system? Given a continuous map Fi's from X to X on a metric space XT, we call this sequence as F1 infinity, and we call this pair as a non-autonomous dynamical system. These Fi's, give us the different, as we had in that particular case, only one function and only one rule. So here we have the Fi's, that means different, these situations can be there affecting the dynamical system. If we take Fi same as F for every I, then the system becomes an autonomous system. And if I go back to the definition of orbit in an autonomous dynamical system, then we know that we define the orbit of a point as Fnx, where n is greater than or equal to 0. In this case, we define the orbit to be, say, x with F1x, compose F1 with F2, apply on x, and like this. And this is the solution of the following non-autonomous difference equation. And as we know that in dynamical system, we have either it is originated from a differential equation or a difference equation. So this non-autonomous turns out to be solution of the following non-autonomous difference equations. And one problem which we face in case of non-autonomous is that in autonomous case, the powers of F, they commute. But in this case, because we are taking the different functions and the situation is very well that they need not commute. And if you put the condition of commutativity of each pair, then it turns out to be very strong condition. So because of this particular problem, many of the techniques which were applicable in autonomous, they don't turn out to be, applicable in non-autonomous case. So techniques of the proofs of the result, they are entirely different in this particular case. We define a point to be periodic point for a non-autonomous system X F1 infinity. If we have some natural number m such that if we take F1, Mn P is equal to P for every n in n. In fact, there are different definitions of periodic point also, but we take this definition of periodic point in our findings. And we say that non-autonomous system is topologically transitive if for every pair of non-empty open sets UV, we have some natural number such that F1n U intersection V is non-empty, and F1n means, as I have written here, we compose F1, F2 up to Fn, and we call this particular composition as F1n. So with this notation, we have the definition of topological transitivity given like this. And the collection of such natural numbers we denote as n f1 infinity uv, those n's which satisfy this particular condition. So that is called as nf uv. And we define sensitivity in non-autonomous case that if we have some delta positive such that if we take any non-empty open set, then this n f1 infinity u delta, which is the collection of those n's which satisfy that there exists xy in U with distance of f1 and x and f1 and y greater than delta. And I recall here f1 n is you compose f1 up to fn. So if this set is non-empty, then we call the system to be sensitive dependence. We call it to be minimal if orbit of every element under f1 infinity is dense. We define M system, which is topologically transitive and has dense set of minimal points. And when do we call a point to be minimal point? If we take its orbit, take the closure, then restrict that system to this orbit closure, and it should be a minimal map. Then we call it to be a minimal point. Now, as we talked about for autonomous case, we talk about synthetically sensitive and thickly synthetically sensitive and sensitive like that. We talk these are stronger forms of sensitivity in non-autonomous case. So we call it multi-sensitive if for any collection of non-empty open sets V1, V2, Vn, we have intersection of n f1 infinity Vi delta is non-empty. Similar are the definitions for thickly sensitive, thickly synthetically sensitive, cofinite sensitive in this particular non-autonomous case. In his paper published in Journal of Differential Equation in 2016, this Huang et al. They showed that for M systems, that means which is transitive and has dense set of minimal points, these relations they hold. That is, cofinite sensitive implies multi-sensitive. This implies sensitivity, and in this case we have the equality. The relation is not true in general, but for autonomous M systems this holds. And we observe that when we define this multi-transitive, thickly transitive, this means these are stronger forms of transitivity in autonomous systems. We observe that these facts, which were true for autonomous dynamical systems, they are not true for non-autonomous dynamical systems. And in each case, we have examples justifying these facts that they are not true for non-autonomous dynamical systems. So the next was that which kind of condition we can put on the system so that we get these results to be true in non-autonomous case. So certain results we have obtained using the conditions where we get that these results are true. For example, this first and second results, they were proved by Liu and Chen without any condition on non-autonomous system to be true. But we observed that their proofs were not correct, and we gave the counter examples, and then we proved these results under these conditions that they are not true in general. But if we take the periodic non-autonomous system or uniformly convergent non-autonomous systems, then the results turn out to be true. And this is an example which gives the minimal and sensitive need not imply synthetically sensitive, which was true in case of autonomous. So we have used this sigma to a space. We can do in general on 0 to k also. And using this Morse-Thue sequence, we have constructed this non-autonomous system. And we observe that this is minimal and sensitive, but not synthetically sensitive. You can see that we are inserting this I map 10 times, then 10 raised to r minus 1 times. So as we go ahead, the gap is increasing, and therefore the system is not synthetically sensitive. Similar thought was given to construct an example where we show that transitive and weak mixing and syndic transitivity need not imply the multi-transitivity. These results were true for autonomous case, but not true in the non-autonomous case. And we have obtained certain results for stronger forms of transitivity. Like we have shown that this in the non-autonomous system, if we take the maps to be feebly open and converging uniformly to a map, then if it is minimal, then and converges collectively, then all these three concepts, turn out to be same. We also talked about, these concepts on uniform spaces, because that is the most general case when we can have these concepts. And this is our joint work with Professor W. And as I told you that certain results which are true for this autonomous system, like it was proved by Banks and et al, that if we take a system which is transitive and has the dense set of periodic points where the space is infinite metric having no isolated points, then it gives the sensitivity. But it is not true in non-autonomous case. So we have found conditions under which on infinite Hausdorff uniform space, we have that these two imply the third condition, with the some conditions on the hypothesis. The next area which we are working is semi-flow, and I will just recall its well-known definition that how do we talk of the semi-flows? We have a semi-group and we have a topological space. We have continuous action of that semi-group on the space. And we define the orbit of an element under this action. And whatever dynamical system we talk about, given a topological space and a continuous map, or in general a metric space and a continuous map, we can also see it as a dynamical system originated as natural semi-flow, where T we take as this semi-group of all positive integers and define the action as Kx to be Fkx. So these types of semi-flows we call as cascades or discrete dynamical systems. We talk about multi-sensitivity and n-sensitivity, strong multi-sensitivity, etc. for semi-flows with respect to a vector. And we have these results when our semi-group turns out to be abelian, that these following concepts, they turn out to be equivalent, like sensitivity, n sensitivity of that semi-flow, or if we take the action of Tn on X and then talk about the n sensitivity. This is the example which shows that equivalence is not true in general for semi-flows, and here our the semi-flow is not almost open. Therefore, here we had the condition that when the semi-flow is almost open, then they are equivalent. So we have justified with example that when the semi-flow is not almost open, then the result need not be true. We have also talked about the product of semi-flows. We know that arbitrary product of metric spaces need not be a metric space. So for studying the product, we have to go for the countable product, countable infinite maximum. So we then, because that was the restriction there, that we cannot study the product in general. So we studied these concepts on uniform spaces and where we can talk of in general the product. So we have defined and studied ergodically sensitive, multi-sensitive, and these concepts on general uniform spaces under the action of semi-group, and studied what happens to the results regarding product. And one thing more I will like to say is the study using the iterated function system. And this was motivated by the following question that again, sensitivity, transitivity of an iterated function system, do they happen at regular intervals of time? And this study was done using the Furstenberg family, which is nothing but a collection of subsets of non-negative integers satisfying certain conditions. So we define this Furstenberg family having these kind of properties. We have studied this F transitivity and F mixing, these concepts using the iterated function system. And lot of studies still can be done related to these concepts. We can talk of this stronger forms of sensitivity and transitivity for semi-flows on general topological spaces. So we are trying to study these concepts on general topological spaces so that we have the more domain to study these particular concepts. And still some problems are left out to deal with, like in case of non-autonomous systems also, topological transitivity, will it imply Devani chaos on intervals? In case of non-autonomous discrete systems, similarly, can we say multi-transitivity will imply Lie or chaos in non-autonomous discrete systems? We are trying to explore to do these studies, using the Furstenberg family and semi-flow, because then we have the most general case where we can do all these kinds of study. I'm happy to just recall here that we have hosted Professor Furstenberg and his wife in our satellite ICM conference in 2010. So I always feel happy that we are using the work of Furstenberg, whom we have personally met and hosted. And he was very happy, and he wanted again to come in our 2012 conference, which we hosted in the 2012 conference, which was done with the help of ICTS in the honor of Professor Dani. And he wanted to come to attend that conference also, but he was having some brain tumor operation, so he could not attend. But he was very much interested to come because he was very happy to attend our 2010 conference. So it was really nice to host him and many other senior researchers and mathematicians. So I want to tell to our budding female mathematicians that try to attend the conferences as many as you can, because you get the opportunity to meet the senior people with whom you can discuss your work and see that which kind of work they have done. And that is really a big encouragement for girls to get motivated to make the mathematics as their career. So I'm really happy to today give this talk, because I hope some of the young mathematicians will get motivated to work in this particular area. I remember when I was doing MSc in 1986 from University of Allahabad, in the class of 106 or 7, there were only 2 girls, me and one more, and there were 106 boys. So when I see my class today of MSc, I see more than 60% of girls, and many of them are very sincere. So I really feel happy that in 25, 24 years, the things have changed a lot. So that is a very good progress in our country. And I tell young female students and faculty who are attending this conference that you should also discuss your work with as many people as you can. It's not necessary that you meet them in person. You can interact through mail, and now we have this other technological platforms where we can discuss our work with others. So that will really give you a boost in your career. Thank you all.
Thank you very much, Professor Ruchi Das, for such a wonderful introduction to this area. So are there any questions from the audience? Please, you can unmute yourself and ask. Okay, so maybe I can begin by asking a question. So, so when you say that one can talk about stronger versions of sensitivity on semi-flows on general topological spaces, so what kind of topological spaces are you thinking of? What
we are trying to define first on the general topological spaces. Then we see when we are trying to prove the result, sometime we have to take say T3 space minimum or uniform space like that. So depending upon what kind of concept we are dealing with, we have to put naturally some condition on that particular space. But to start with, it can be defined on general topological space.
I see. So, so can you probably give some reference of what kind of results
in
exist?
fact, I have during the talk slides, I have given some references or I can, give you separately also some list if you want.
Okay,
that
sure.
way. So
Sure,
I
that
will
will be,
send you in
I'll
the
contact
mail.
you. I'll
Yeah,
contact you,
so-
surely.
So naturally, we need the compact spaces sometime when we work with. So depending upon what kind of results we are looking for, so we put the conditions in the hypothesis. But as far as definitions are considered, we can define and then look for conditions on the space.
Okay.
But a lot of work is being done in this area. So
it's a very rich area of research. Yes.
Yeah.
So Professor Ajit Iqbal Singh has a comment in the chat box. Ma'am, would you like to unmute and say something?
Should I stop sharing?
Yeah,
You can.
no,
Yes.
no, please keep sharing. A
Okay.
wonderful talk.
Thank
Really
you.
wonderful talk. She put dynamical systems on a strong footing. And let me say that the strong footing also keeps moving. So that makes it even more beautiful.
Thank you.
And
Thank you
butterflies
so
are
much,
known
ma'am.
for beauty. Thank
Yeah.
you very much. All the best. All the best.
We always feel encouraged seeing you so actively involved in mathematics. And I wish that I also continue this.
And with more vigor. Okay. because you are dynamic.
I tried to keep the things very simple so that means general audience can understand. But if
Ruchi,
anybody
now,
is interested, I can give the references to study the proofs and all.
Yes.
Ruchi, now you have some girl students, right? One of them
Yeah.
finished and
Yeah.
there are more?
Yeah. One is already awarded.
Yeah.
Two are awarded, in fact,
PhD
degree. And
I remember one of them in our IWM activities. So.
yeah. She went to present a poster and a talk also.
Mukta. Yeah, this year, unfortunately, because it's online and a shortened version, we are not able to have students' presentation. Otherwise, we have students' presentation as integral part of these talks.
Yeah, I really appreciate. I appreciate the effort of IWM to encourage students.
Thank you, Ruchi.
Yeah. Thanks a lot once again.
No, it was very nice to have you here.
Thank you. So,
yeah, we have 5 minutes more. If anybody wants to say anything before Tammy Zarasi's talk starts. Professor Tammy Zarasi is here. So maybe she can be made a co-host. But if anybody wants to make any comment, anything, we have some time. She is a co-host already.
I would just like to say that in Delhi University itself, Shachi Srivastava, she works on dynamical systems on Banach spaces, operator value dynamical systems. And I'm not at Delhi University, but my association with the university is much more. And I work on dynamical systems on operator spaces, and Ajay Kumar School also works on such things. Thank you.
Yeah, ma'am, we are already working on linear dynamical systems also. So I have not touched that area because of the time constraint.
Good, good, good.
And I keep asking. I keep asking her these questions.
Yeah.
Yeah, Sachi keeps asking me sometimes, but yeah, I should also get together sometime.
Yeah.
Yes, I think we should. I was just looking at this talk and several ideas, as usual, at the time.
So, should we start the next talk?
Maybe
Nikita?
we can do a trial.
Yeah, Professor Tamizarasi, can you share your screen? Nikita, maybe you can ask. She's there, I know.
Yes.
She's already a co-host.
Yes, yes. Professor Tamizarasi. She's there, but
Because it's supposed to be at 4, maybe she's this.
Yeah, I can see Tamirarsi's.
Yes, I'm here, madam.
Yeah.
Hello.
okay. Hello.
Can you please
Can you share your
Yes.
files?
and put your video on, please?
Tamirarsi?
Yes. I will share the screen. Can you see?
Yeah.
Yes, we can see your screen. Yes.
Can
Yes. Can you make it full screen?
Yes, yes. Control H. It's in full screen mode only.
Oh,
Okay, it's fine. I think
okay.
we can.
Control H.
This
I
will.
think, it's cut. We can see only partial, isn't it?
Is it?
Can you see the full slide?
I think
I
so,
can see
because
the
on the
full slide.
bottom the panel is visible. Right?
Yeah, we can see.
I'm able to see the full slide.
I'm also able to
Yes,
see.
yes.
Can you?
1 minute.
Neela, you can also increase the size of the actual thing by pulling on the separation.
Yeah.
Professor Tamizarasi,
Yes,
can you
yes.
change your video a little bit? Then we can see more of you. We couldn't see well.
Okay. Is it visible?
Yeah. Okay.
So maybe you can try Control L.
Biggest screen. Control L.
Or you can go to view. No, this is.
Is it okay?
No, not this. Just go to view on the top panel. File, edit, view.
View.
And there should be a full screen mode. Go down, please. Full screen mode.
No, it's not visible. For Zoom is there.
There is. I can see full screen mode in view.
In view.
Yeah, full screen mode. Go down.
Below read mode.
Yes.
Just go below. Further.
Yes. Is it okay?
Yes, it is perfect. Yes.
Okay.
So Riddhi, I think we can.
Yeah, Nikita, please introduce Professor Tamizarasi and chair the session. Thank you.
Okay, thanks. Thanks, Riddhi. It is my pleasure to introduce Professor Tamizarasi from VIT University at Vellore. She retired as the director of Cwm Institute for Postgraduate Studies and Research, Puducherry in 2017. And since retirement, she has been at VIT. Her research interests lie in integral systems, and she has 38 years of experience in teaching and research. Professor Tamizarasi has co-edited a book titled Discrete Integrable Systems, which is published by Springer, and I went over the book and I saw that she has also contributed to writing several chapters in the book. So, and she has also guided a large number of PhD and master's students. So today she's going to talk about discrete integrability, blending, Nevelina theory, and singularity confinement. So over to you, Professor Tamizarasi.
Yeah. Good evening, friends. My sincere thanks to Professor Nalini Joshi, my friend and collaborator, Dr. Riddhi Shah and Nikita for introducing me. In my today's talk, I am going to give a recent development in discrete systems. We know that the most complicated models in mathematics are nonlinear differential equations and its discrete counterpart, nonlinear discrete equations. In this lecture, a recent development for integrability in nonlinear discrete equation is discussed. Singularity structure of solutions plays an important role in obtaining solutions to differential or discrete system. In this direction, a simple and elegant discrete integrability detector by name Singularity Confinement was first introduced by Grammaticos et al., my research group in Paris. This test is combined with the Nevelina technique, which is an excellent 20th century complex analysis tool developed by Nevelina while extending the fundamental theorem of algebra to meromorphic functions. This lecture focused on how singularity confinement is blended with the Nevelina theory to provide a discrete integrability detector. This is right time to know about the integrability. What is integrability of a differential equation? An ODE is said to be integrable if there exists a well-defined solution about all movable singularities. Again, we should know what is movable singularity. If the position of the singularity keeps changing with the initial condition, then we call it as a movable singularity. There is no unified classical definition for integrability. Mostly we are working only on working definition. Integrability is a more constrained property than solvability. For example, consider this particular equation. This is a solvable system. Look at that, the solution is given by W is equal to tan of something. This is solvable but not integrable. It is because it has a logarithmic singularity at the point Z is equal to Z naught, which may be an initial condition in the system. It will keep changing once the initial conditions are changed. Integrability of an ODE related to the singularity structure of its solutions in the complex plane. Linear ODEs are integrable because the singularities are fixed. They are decided by the coefficients of the equation. So suitable redefinition of the solution is possible. Nonlinear ODEs, the singularities are movable. In fact, this is the problem, movability of the singularity. The most successful integrability detector for nonlinear ODEs is Painlevé property. This property was successfully extended to PDEs also. What is Painlevé property? An ODE is said to possess the Painlevé property if all of its solutions are single valued about all movable singularities. Equivalently, the only movable singularities of solutions are at the most can be poles. ODEs of Painlevé type played a very important role in integrable systems. Integrable nonlinear ODEs are identified using Painlevé property. In 1884, Fuchs showed that when he considered all the first order equation in the form dw dz is equal to a function of zw, where f is rational in w and analytic in z, he has identified that only this equation is possessing Painlevé property, showing that Riccati equation, this particular equation is called the Riccati equation, is the only first order ODE possessing Painlevé property. Later, Painlevé and Gambier solved this particular problem. For second order differential equation, they considered the equation in this form, where f is polynomial in y dash, rational in y, and analytic in z. When they considered this second order differential equation, they identified only 50 second order nonlinear equations are possessing Painlevé property. Among them, only 6 are new, introducing new special functions as solutions. These special functions are called Painlevé transcendents. Some of the Painlevé equations are listed here. 4 equations I have listed. Painlevé test is an algorithm designed to determine the necessary condition for differential equation to possess the Painlevé property. Painlevé equations are irreducible. They are integrable through associated linear isomonodromy problem, popularly known as ISI method or lax linearization. They are having special solutions, special functions as solutions, and they are called Painlevé transcendents. Painlevé equations, they played a key role in the integrability of ODE to identify new unknown integrable systems, not only ODEs but also PDEs by reduction. They were the center of attraction for more than 100 years for researchers in this field. Later, these concepts were extended to discrete systems also. Why discrete? Due to the characteristic of time. For physical and practical problems, data can be captured only at discrete intervals of time. Therefore, discrete models are more frequent in practical and physical setup. When Shoghat worked on orthogonal polynomials, this particular equation appeared in the year 1939, but before the knowledge of continuous limit. At that time, no idea about discrete equations was available. So this was not identified in that year, in 1939. But later, after the idea of the continuous limits, people identified that it is a discrete equation. That was the beginning of discrete systems. Discrete dynamical systems, they are considered to be more fundamental because one can always move from discrete dynamical systems to continuous systems. The explosive growth of interest in discrete integrable systems forced people to look for integrability detectors for discrete systems. Continuum integrability is well established. Discrete integrability is new, much more to explore. Owing to the roaring success of Painlevé property, people were started looking for analogous concepts of Painlevé property for discrete equations. A number of methods were introduced in recent years. Singularity confinement was the first discrete integrability test introduced by Grammaticos et al. Is a simple and elegant test. What is singularity confinement criterion? If the dynamics leads to a singularity, then after a finite number of iterations, the singularity should disappear without essential loss of initial information. Let me establish this particular concept with an example. Consider this discrete equation. It is clear that it has a singularity at xn is equal to 0. We will do the singularity confinement test. So you take this x0 as epsilon. We will always take epsilon tends to 0. And the initial condition, we will take it as x minus 1 is equal to u. As epsilon tends to 0, x0 is 0. Let us take the first next step. x1, it is like that. As epsilon tends to 0, this x1 tends to infinity. Let us go to the next iteration, x2. We will have in terms of x1 and x0. Substitute the values of x1 and x0 in terms of epsilon and rearrange. After that, take epsilon tends to 0. You are getting x2 tends to 0. So the singularity that appeared at n is equal to 0, it is disappearing when n is equal to 2. But there is no initial memory in this step. So let us do one more iteration. So go to x3. Again, as usual, when you substitute the values for x2, x1, rearrange, take epsilon tends to 0, you will be having x3 tends to u. So the initial memory is retrieved. Therefore, this particular discrete equation is having a singularity pattern 0, infinity 0, and the initial memory is also retrieved. Therefore, this system passes singularity confinement test without any problem. What are the salient features of the singularity confinement test? It is very simple and elegant, practically very easy to check. Singularity confinement is used to derive discrete Paine-Levé equations. It's been believed that singularity patterns are the same for autonomous and non-autonomous systems. So this test is used to generate integrable non-autonomous systems from integrable autonomous systems. Autonomous equations with constant coefficients. At that time, Jarmon, Internita, and Claude Viale counted that the singularity confinement test need not be sufficient for discrete integrability. They gave a counter example in this form: xn plus 1 plus xn minus 1 equal to xn plus a by xn square. This passes the singularity confinement test without any problem. The singularity pattern is 0, infinity, infinity, 0. So singularity confinement test is obtained without any problem, but it is a well-known chaotic system. So people started looking for necessary conditions for a discrete integrability detector. Oblowitz and Hulbert introduced a novel complex analysis-based discrete integrability detector. They considered difference equations as delay equations and used complex analysis tools for that study. What are all the observations when we move from continuous to discrete? This is very, very important. Singularity structure for integrable and non-integrable systems reveal the secret that integrability of discrete systems is encoded with the singularity structure of the solution at infinity. I will explain this concept with examples. Solutions of well-known discrete integrable systems are of finite order, but at the same time, finite order solution is only necessary but not sufficient for integrability. So Oblowitz and Hulbert, they combined it together with the finite order solution to check for the absence of digamma functions in the series expansion of the solution together with the finite order solution. This is a very nice integrability detector, but checking for the absence of digamma function in the series expansion is practically difficult. So based on this approach, our research group blended Levellina theory and singularity confinement test to come out with a discrete integrability detector, which is comparatively simpler. From continuous to discrete, we have to observe the following observations. See, in the normal continuous system, we are adding arbitrary constants. In this place, we have to add arbitrary periodic functions in the case of discrete systems. Solutions of integrable as well as non-integrable discrete systems, they display the same meromorphic structure in the finite complex plane. So the integrability of discrete systems depends on the asymptotic structure of its solutions at infinity. Nevanlina theory is a tool for this. It is used to identify the discrete solutions which should be of finite order. So we use Nevanlina theory only in this aspect. The counterexample produced by Jarmo and Viale, we have studied that in this example in this slide. That is, we were checking for the whether the solutions are of finite or infinite order. So we observed that discrete equations can be represented as delay equations in the complex plane. From differential to discrete, two major observations are made. One is integrability of discrete equations, solutions should be of finite order. Then either in the sense of Ablowitz and Halpert, absence of digamma function in the series expansion of the solution, or complement finite order solution with a singularity confinement, which is proposed by Grammaticos et al. Any one of this will be a perfect discrete integrability detector, and we claimed that singularity confinement together with the finite order solution is a simple, elegant, discrete integrability detector. Let us see this in the following example. Yanagihara considered this particular difference equation. This system includes both integrable as well as non-integrable, but this system has meromorphic solution in the finite complex plane. So where is the indication for non-integrability? Because this includes both integrable as well as non-integrable systems. We concluded that the difference may be at infinity. Let us establish this fact using another example. Consider this discrete equation. It has a solution in this form. So the solution is well defined. Therefore, the system is integrable. The continuous counterpart of this equation after the continuous limit, it is yz plus 1 minus yz is equal to this. Take n is equal to 1. This will be reduced to dy by dz is equal to 1 by z minus c, which has a logarithmic singularity. So it is a non-integrable system. The discrete version is integrable. The continuous version of the same equation is non-integrable. Why this drastic change? It is very clear that the behavior of solutions at a finite point in the differential equation is reflected at infinity for the corresponding solution of the discrete system. So for discrete system, the study of the behavior of its solution in the finite complex plane is alone it's not sufficient. You have to go to infinity also. So the behavior of its solution at infinity is essential. The only way for this is the Nevanlina theory. Let us recall some observations in this connection. There was an important observation by Arnold and Wesselo. They observed that the growth properties of solutions are essential for integrability of discrete equations. So, looking for finite order solution could be a good direction. In that angle, Yanagihara studied this example, yz plus 1 minus yz. This is a rational function right at side. In the irreducible form, numerator degree is p and denominator degree is q. He proved that it has a non-trivial meromorphic solution of finite order if maximum of p comma q is less than or equal to 1. Ablowitz and his group studied the same property for a second order equation like this. They considered both additive as well as multiplicative. They admit finite order meromorphic solutions if max PQ less than or equal to 2. In the light of this result, the counterexample produced by Viale and Jarmo, so it is the solution of the system, which is the counterexample produced, is of infinite order. So it is a well-known chaotic system, but passes the singularity confinement test. We concluded that finite order is a necessary condition for discrete integrability, and so the study at infinity is important. The cream of Nevanlinna theory is that he was trying to extend the fundamental theorem of algebra from entire functions to meromorphic functions. The fundamental theorem of algebra, later it was formulated in the form of value distribution theory. Degree of the polynomial played an important role. So the fundamental theorem, when they were trying to extend that to entire function, that is nothing but the Picard's theorem. So the degree of the polynomial is replaced by the growth of the max function. But when they moved from, it took nearly 100 years to come to this development. I think after Picard's theorem, more than 60 years they took to come to a conclusion. They replaced, Nevanlinna replaced the max function MRF by TRF, which is called the Nevanlinna characteristic function. It is equal to sum of two concepts. One is MRF. MRF is the same as max function, and NRF is the pole counting function. This MRF will be this NRF is the pole counting function for entire function. I'm sorry, only NRF is equal to 0. So this is an analogous concept of the max function. Your TRF is the analogous concept of max function. But this Nevanlinna characteristic is having beautiful properties. Look at that. The growth of the function 1 by f and f are the same. The growth of the function f minus a and f are one and the same. The growth function for this p by q polynomial rational function in f, this is same as supremum of pq trf. So like that, even if you consider the product function, it is less than or equal to the sum of the Nevanlinna characteristic. Even for the sum, it is less than or equal to sum of the Nevanlinna characteristic. You multiply this in any combination, this will be the result. It has been generalized to any number of products like this. Hilbert established the last result. This only we will be using for discrete system in various steps. So we considered three-tiered approach for discrete integrability. The first step is restrict only to autonomous system. Why we do so? The growth of the coefficient should not affect our study of the growth property. So at this level, we will restrict only to autonomous systems. Filter all autonomous discrete equations whose solutions are of slow growth. So at this stage, we discard all the autonomous discrete systems whose solutions are having infinite order. We are rejecting them. Next, in the second step, we are going to apply the singularity confinement test in the filtered discrete equations of the first step. And in the third step, we will de-autonomize that to remove this restriction autonomous system. We believe that the singularity pattern for autonomous and non-autonomous systems are the same. Therefore, at this stage, we will de-autonomize. It has already passed the singularity confinement test, and we know that the solutions are of finite order. So both the conditions are satisfied, and whatever you are getting after the third step, definitely that will be integrable discrete equations. Non-linear, integrable discrete equations. Let us consider that in the overall setup, you consider discrete equations of this form, where the left-hand side, as far as possible, we will rearrange them in the polynomial form. Right-hand side, you can have it in the rational setup. This is only for the convenience that we can calculate the Nevanlina characteristic if it is in the polynomial form. Following the AHS hypothesis, we will calculate, we will rearrange that using the last result I told you. The last result we will be using. So when you apply this, so this will be, you will have one TR plus 1 out of this term and another TR plus 1 out of this term. So we can arrange them as U multiplied by 1 plus epsilon TR plus 1x, and whatever you have in TRX, you call it as V, and the right hand side do it Nevanlina characteristic separately without mixing the terms in the left hand side, you call it as W. So we can rearrange that TR plus 1 X is greater than or equal to W minus V by U into 1 plus epsilon. You call this quantity as lambda. It is very clear that if this lambda is greater than 1, then the rate of growth of this Nevanlina characteristic tends to infinity. Therefore, the function will be of infinite order when lambda is greater than 1. So, naturally, we get the conclusion the mapping is of finite order if W less than or equal to U plus V. Identifying the values for W is the Nevanlina technique. So let me explain this with one example. Consider the discrete Painlevé equation 4. We have already applied a singularity confinement to this, and we have got this as a discrete Painlevé equation. Now we want to get the condition for the solutions to be of finite order. What extra condition will be imposed on this equation we will study. So TRF, when you apply, product will be sum. When you group the terms, you will get the value for U as 2, value for V as 2, and therefore when W greater than 4, this Xn is of infinite order. So for finite order solution, you should restrict W less than or equal to 4. So the right hand side, which is the value for the degree of the polynomials, maximum admissible will be 4. So at the most, P and Q can be quartic in order to have discrete integrability. The solutions will be of finite order and the system will pass the singularity confinement test, and absolutely for when you restrict P and Q up to degree of 4, this system is a discrete integrable system. So like that, we applied Nevanlina characteristic to all the QRT mappings. So what is the conclusion? In the search for discrete analog of Painlevé property for the last 25 years, we feel that singularity confinement with Nevanlina technique is a practically simple discrete integrability detector. We believe the requirement of slow growth will not disturb the de-atomization. This approach is extended to all QRT mappings, which include discrete Painlevé equations. For a large number of discrete Painlevé equations, even by this time, lax pairs are known. For most of the discrete Painlevé equations, geometrical descriptions are given through Weil groups. In particular, the solutions of discrete Painlevé equations are constructed from the solutions of non-autonomous Hiroto-Miwa equation. So we believe that a much more strong group theoretical based discrete integrability detector can come in the future. Our discrete integrability again confirms that discrete Painlevé equations are the only integrable systems from the QRT family. concerning the special limits to DP4, the additive discrete Paine-Levé 4 and multiplicative Paine-Levé 6 are yet to be explored. Problem is still open for lattice equations. We feel that this method can be used to tackle the above problems. Lastly, finite order requirement was the missing ingredient in singularity confinement. So, with this prerequisite, singularity confinement is a powerful integrability detector. With this, I am concluding my presentation.
Thank you very much, Professor Tazimarasi. Are there any questions? Are there any comments? There is some comment in the chat box.
Yes.
Professor Ajit Iqbal Singh, would you like to say something?
Yeah, that will be better.
It's a great talk, I said, and I was reminded of discrete geometry and discrete complex analysis lectures at ICM 2010 by Stanislav Smirnov, and also which refers to work by Bobenko. And then recently Rukmani Day gave a talk, and she also mentioned discrete differential geometry, and then she told us that Bobenko has a website on discrete differential geometry. So this, you have to study continuous systems through discrete systems, and we have been exposed to powerful methods by the speaker. Thank you very much.
Yes, yes, madam. Bobenko group is studying this lattice equations. I think they have a very big project. In future, we can expect very good results from that group.
And I mentioned ICM 2010 talk because that is expository level, and it is a complete survey, and it introduces people in an interesting way. But obviously there is a lot of work after that.
Yes, yes, yes. There was tremendous work after 2010 after ICM. Even we were also there in Hyderabad. Yes, there was lot of results after that.
Thank you, Professor Ajit Iqbal Singh. If there are no questions based on the talk, we have, I think our closing session starts at 4:45, so we can spend 5 minutes in knowing about your academic journey and how it was when you were an undergraduate student in mathematics, and how do you feel today?
Yes, Nikita, I studied in Ramanujan Institute for my master's degree. So really, I had the opportunity to study under great teachers, Professor Rangachari, Professor K.S. Padmanabhan, and we were the first batch of MSc students for Ramanujan Institute. And really, I had a very good exposure to research. I had an opportunity to join Tata Institute also. Since I was very much afraid of the atmosphere there in the Tata Institute. No, it was my bad luck. I didn't join there. After that, I completed my PhD. My PhD is in complex analysis. My husband, late Professor Tamilmani, is a great scientist. He was an FNA, FNASC. I lost him in the year 2017. He was a big motivation for my second innings career in research. I was working for Government of Pondicherry. I had 40 years, now this is my 43 years of service in teaching. and equally I have that research exposure also. We have a very strong group in Paris and Tokyo, Australia. Nalini Joshi is one of my collaborators, very dynamic person, and I am proud to say that she has reached the highest position, being the vice president of IMU. I am really proud of her. I feel proud to work with her. In spite of her busy schedule, no, she used to interact with me. I specifically thank my collaborator, Professor Basil Grammaticos. I have been almost to the shattered condition after the demise of my husband. So only after joining VIT, no, with the students, I'm forgetting my loss. Anyhow, no, there is a very big opportunity for girl students. Everybody is encouraging. Everybody is encouraging. Plenty of opportunities are available. So the only thing I want to advise girl students, don't look at the barriers that I did in my MSc days. You must come out with boldness. You must face all the problems. You must choose mathematics as your career. No, the one person who brought me back to research, I cannot forget, Professor Yuvat Postman Swasberg. When I met her in 1996 at Pondicherry, when my husband organized a Simpa school, at that time only she recognized me as a mathematician. Why are you sitting inside the house only taking care of teaching and cooking? No, 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 this is not the end of life. You must come for research. Then she only invited me to Paris, under a French high-level foreign ministry fellowship. I went in the year 1998. And after that, continuously, I was going abroad for my research activities. Mostly myself and my late husband, we used to be in abroad for our research career in the month of May and June. Like that, we carried our research. Even though I had a small gap after the birth of my children, I was able to cope up with research activities, and still I am doing whatever I can do. Even at this age, I concentrate on research. If not 5 or 6 papers in a year, at least 1 or 2 papers I am publishing. So my sincere advice to all the girl students, mathematics you study for its beauty. That is very, very important. Don't worry about your career and other things. Maths has its own beauty. So for that beauty, one who enjoys logic and reason, definitely mathematics will be a very great career. And there is a very big opportunity for women mathematicians in India, I think, because most of the people in my age group will be retiring very soon, and there will be a lot of opportunities in the top research institutes. So if girl students enter into mathematics research career, their future will be very good. This is my take.
Thank you very much for such encouraging words. It's really inspiring.
Yeah, it's a pleasure to share my experience.
And if I'm sure you'll be okay if participants contact you over your email.
Oh, sure. I didn't give you any reference. I have given you one piece of research work that has happened when I joined that group. I was observing. I presented the matter in such a way that how research should be carried out. A piece of counterexample was given to a concept, and how the concept were developed to rectify that structure of the counterexample in order to give a full-fledged integrability detector. So like that, how one should do research. I wanted to convey that message. That is why this piece of lecture I took.
It was really wonderful. I think there was complete justice to what you wanted to do.
Yes, I feel that. You concentrate on one particular thing. Maths is a big ocean. You cannot explore everything there. But whatever you study that deeply, and whoever questions you, you should be in a position to answer. You should be in a position to defend yourself when you say some concept.
Yes. So on this note, I will thank both the speakers of this session, Professor Ruchi Das and Professor Tamiza Rassi, for wonderful expository talks, I would say. And Riddhi, if you are here, you can take over.
Yeah, you can share my email ID. If anybody is working in this field, I'm ready to discuss with them.
I'll put it in the chat box, and you can stop sharing your screen.
Yeah, you mean the first page? Okay, okay. The next lecture started. Okay, thank you.
Thank you, Professor Tamizmani, Tamiza Rassi. Actually, I can't figure out what is your first name in this.
I am Tamizmani. Tamizmani is my husband's name.
Ah, okay, Tamil.
I'm Tamizmani.
Okay. Thank you very much for this lovely talk and inspiring words. I'm sure our young students would be very much inspired by your personal journey. And I would also like to thank Professor Ruchi Das and Professor Nikita Agarwal. Professor Ruchi Das also gave a very good talk, and that's in an area close to my heart, dynamics, and yours is also a different kind of dynamics. Yes, I should learn more. I don't know this area so well. Yeah.
Thank you. Thank you, Professor Riddhi. I really feel happy and honored that I was given this chance to interact with the participants.
Yeah. Thank you very much, Ridhisha, for giving me an opportunity like this. We'll meet in future occasions.
So we will start our closing in about 2 minutes at 4:45. And if anybody has any comments, meanwhile, can give the comments.
This share, the screen share can be removed, right?
Yeah, maybe we can ask her to share the screen and see if it works.
Unshare maybe. Yeah.
Okay.
Hello, Marie-Françoise.
Bye.
Bye,
Yes, yes, yes.
Of course,
you're here for the
you will be there in
ceremony. Ma'am, be there for the closing ceremony.
Yeah, please be there. That's what I was saying.
As we have, can you hear me?
Yes, we can.
Yeah. If you allow me, I will take maybe 1 minute to share a nice story which is very relevant to this conference. So I heard this from my collaborator, Nasser Reza, who is in Paris now, but he is originally Iranian. So he was a math Olympian. So in Iran, they actually train the juniors by the senior math Olympians who are about to go to the math Olympiad. And he was telling me this story that one day they were doing some graph coloring problems, list coloring problem. There was an open problem, which was this list coloring conjecture of planar graphs. And the lower bound was known on a very big graph, and people were searching for smaller graphs. Then a very small girl who was maybe 15-year-old, she was also in the class, and the teacher said, maybe you guys can try to solve this open problem. The girl came back next day with a solution, which is still the best known solution. And the girl went on to win a gold medal later on in Olympiad, and afterwards was the first Fields medalist. She was Mariam Mirzakhani. So just wanted to share this very nice story. Her first paper was in graph theory, even though she worked in completely different topic afterwards.
Beautiful. Beautiful story and beautiful She was here in 2010
Yes, yes,
in
right.
our ICWM, the first Women in Maths meeting. And
Right.
I still remember her talk. It was very inspiring talk. That time I didn't know her. And later I heard her talk in 2015 in MSRI Berkeley. And
Right.
the whole conference, she couldn't sit because of her condition. So she would stand in
Yes,
the
yes.
balcony and shoot questions at the audience, I mean, at the speaker. And it was, her energy was amazing.
Right.
Yeah. So
I
should we
think
start?
we
Yeah.
can start. Yes.
Yeah. So, hello, Marie-Françoise. Nice to see you in person.
Yep,
Yeah.
to be with you.
Yeah.
Hello.
So, on behalf of the Executive Committee of Indian Women in Mathematics and Scientific Committee and Organizing Committee of this conference, and also the host of this conference, IIT Dharwad, I welcome you, Professor Marie-Françoise Roy, our guest of honor, and I welcome all the participants and dignitaries in this closing ceremony. It's a pleasure and honor to introduce Professor Marie-Françoise Roy, who is our guest of honor today in the IWM Annual Conference closing ceremony. Professor Roy is the chair of Committee for Women in Mathematics of International Mathematical Union since its inception in 2015. She is an emerita professor of mathematics at University of Rennes, France. Her research area is real algebraic geometry, and she's a specialist in algorithms of real algebraic geometry, which is her current area of research. Professor Roy has dedicated her life to mathematics teaching and research, as well as to promotion of women in mathematics. She was a founding member of the European Women in Mathematics since 1986, and also its convener during 2009 to 2013. She was the first president of the Association for Women in Mathematics in France during 1987 to 89, for which she was instrumental, again a founding member. She was a president of the French Mathematical Society during 2004 to 2007. She has been instrumental in initiation of the project, A Global Gender Gap in Mathematics and Natural Sciences. She has worked extensively on promoting women in mathematics in developing countries. For example, she was a co-director of an ICTP OEA school in Niamey in Niger in 2005. She was the coordinator of RAGAD network, which stands for African Network of Algebra and Geometry Applied to Development during 2009. And she was a scientific advisor in charge of Sub-Saharan Africa for ICPM SIMPA during 2007 and 13. She was also a facilitator for 2 research projects in Africa for Simon Foundation in 2013 and 2018. The list is very long, but let me just mention that for IWM, she has been a staunch supporter and has encouraged and promoted our IWM activities throughout this period. She has also been an IWM distinguished visitor and visited India just a year ago in February 2019 and gave talks in colleges in Mumbai, Jaipur, and Jodhpur. I now invite Professor Marie-Françoise Roy to release the logo for IWM.
Okay, many thanks. In fact, my trip to India was in 2020, and it's nearly my last trip before all this lockdown due to COVID. So many thanks again for this wonderful invitation. So it's really a great pleasure for me to be with you today. And that's, of course, what these video conferences are making possible, because I'm in fact in my house in close to Rennes, and I'm very happy to be with you. So I've never released a logo in my whole life. I mean, you made a list of things I did, but I didn't release a logo. But I think so. I know that IWM missed a logo, and I think then after we just release it now, there will be some explanations about the meaning of the logo. Yes.
Sagnik, can you help?
Yes, I'm playing it.
Okay, Indian Women in Mathematics, new logo, please.
Yeah, please, there is a suggestion of unmuting and clapping, so we can do that.
Okay, so it's important for an association to have a logo, and I think now we're going to know the meaning of that logo.
Yes, I think Professor Srimay will be taking up for this. Okay.
Hello, good evening. Can you see my slides and can you hear me?
Yes, yes, thank you.
Yeah, so I have the honor of speaking for a short while about the logo of IWM that has just been released by Professor Marie-Françoise Roy. A number of designs were under consideration for selection as the IWM logo. And let me just put this on slide share. Okay, here we are. So as I said, a number of designs were under consideration. And this design of the logo was selected after a couple of rounds of voting among the EC members of IWM. So here is the concept behind this IWM logo. The basic concept of the logo design is about connections and collaborations. The design uses the initial letters of Women and Mathematics, WNM, as a monogram to represent the organization. The visual representation of the letters also depicts two hands coming together to make a connection. The connections are implied at two levels, between women and mathematics and between women mathematicians. They also connote networking, collaboration, and togetherness, which the organization exemplifies. The repetitive visual elements establish a visual rhythm, making it dynamic and harmonious. The color scheme of the logo is based on the Indian tricolor, reflecting the Indianness. In general, the logo is conceived to be simple and direct with a play of letters. So now a word about the designer of the IWM logo. This is Dr. D. Udayakumar, who has designed this logo. He holds a bachelor's degree in architecture from the Indian School of Planning and Architecture of Anna University. He also holds a master's and PhD degree in design from the Industrial Design Center of IIT Bombay. Currently, he is my colleague at IIT Guwahati, where he is an associate professor and head of the Department of Design. But most Indians know him more so because he is the designer of the Indian rupee symbol, the symbol for the Indian currency. So here I would like to take the opportunity to thank the Committee for Women in Mathematics of IMU and especially Professor Marie-Françoise Roy for initiating this whole process of designing a logo for IWM and also actively supporting it by sponsoring its creation. So many thanks to Professor Roy for this. And I would like to hand over to her to say a few words in this closing ceremony. So let me just stop my screen share.
Okay.
Yes. Over to Professor Roy.
Okay, so do you see my slides?
Yes.
Do you hear me?
Yes.
Fine. Okay. Very good. So first thing I want to say that I'm really very happy with the logo, and especially now that you've been explaining its meaning. So you should not forget to send it to Cwm so that we can insert it on the website wherever we talk about Indian women in mathematics in the website. Okay, so many thanks for inviting me to this closing ceremony. Professor Ridisha has been saying very kind words about myself, so you know a lot of things about me already. So I want mainly to talk about this Committee for Women in Mathematics. So as it was said, it was created in March 2015 after ICM Seoul. And it's the only international committee for women in mathematics. Of course, it's following a lot of former initiatives like, for example, ICWM, which was organized in India, as was just mentioned. And we have a website, which is just under Math Union, which is the IMU website.org. It's just CWM. So let me tell you about the members. So it's a small committee with 10 members. The liaison person with the IMU EC is Carlos Koenig, the IMU president, which is something very important for us. I'm the chair of the committee. The vice chair, there is a typo here. Sorry. The vice chair is Carolina Raujo from Brazil, and there are members all over the world. And we have Neela Nataraj from India, who's a member of the committee and very active in the grant management mechanism. So we have two male members, Alejandro and Tony from Canada and Gabon. All the other members are female, and you can see they are all over the world. Basically, there are two from Asia, Motoko Kotani from Japan and Neela from India. And this is the picture of the committee when we had the first meeting at ICTP. For those who know ICTP, you see the beautiful landscape from the terrace of ICTP. So this is the IMU president. And as you can see, I'm here. Carolina, the vice chair, is here. This is Neela, and these are the other members. Maybe I should mention a special guest, who's Julia Pestova, who's organizing who's from the local organization committee of the new ICM in St. Petersburg, and we are collaborating with her. Okay, so what is our committee doing? Well, we have facilitating contacts between organizations for women in mathematics all over the world, and there are many of them. Indian Women in Mathematics is an important one, but we have also the Association for Women in Mathematics in the US, European Women in Mathematics, African Women in Mathematics, many national groups and committees already in existence, and we are now also encouraging the formation of new networks in Latin America and also in Asia. And of course, IWM is playing a key role also in this new network in Asia. So we have a website that I mentioned already. This website is the only platform which is collecting information about all the activities for female mathematicians taking place worldwide. And we have 39 individual countries which are contributing with information on their activities. So it's really providing a way for women to contact each other and give also greater visibility to what they do. We have an annual call, which was already mentioned. And the logo, for example, was sponsored through this annual call. And we are supporting Indian women in mathematics since 2016, which is the first year of the call. And we've been also supporting other countries in Asia. I'm mentioning Asia because India is in Asia, but of course we are also supporting activities in Africa and Latin America. And so on. But we have been in Asia, we've been supporting Indonesia, Iran, Japan, Kazakhstan, Nepal, Turkey, Uzbekistan, and Vietnam on top, of course, of India. We have also the so-called Cwm Ambassadors. So that's more than 150 people worldwide. And these people are just, their task is to disseminate information we are sending from Cwm and also send to Cwm information about their activities. That's why, for example, I requested the logo, because once we have the IWM logo, we are going to be able to use it. And we have a lot of Cwm ambassadors in Asia. Maybe even this list is not totally complete, but from Bangladesh, Cambodia, China, India, Indonesia, Japan, Kazakhstan, Korea, Kyrgyzstan, Malaysia, Nepal, Pakistan, Philippines, Thailand, Uzbekistan, Vietnam. And also the parts, and I should have included in fact Laos in these parts. And then we have also from the more, so sorry, I don't remember the name in English, in French. We say Moyen-Orient, Middle East, yes, Middle East countries from Iran, Iraq, Israel, Lebanon, Oman, Saudi Arabia, and Turkey. Laos should be in the other list. Sorry for that. Okay, so the Gender Gap in Science project was also mentioned. So it was a project which existed from 2017 from 2019. It's an interdisciplinary project trying to measure and to reduce the gender gap in science. So it was a big collaboration between 12 organizations, including IMU for mathematics and IUPAC for applied and theoretical chemistry. And it was funded by the International Science Council. So you can see more details about this project at this website, gendergapinscience.org. And we have a book that you can, which is freely available on the net. So you have a link here. I'm going to send my slides, so you will have all the information in my slides you can recover easily. So it also can be printed on demand. So I think it's a valuable resource to know what we did in that project. So now I want to insist on WM Square, the World Meeting for Women in Mathematics. So it's kind of follow-up of the International Congress for Women Mathematicians, which were organized in India and then in Korea. So we had the first one in Rio at the occasion of ICM 2018 at the satellite meeting. It was the day immediately before the ICM, and we are going to have exactly the same structure in ICM 2022 in St. Petersburg. So it has already been approved as a satellite event, which is also going to take place just the day before ICM. Hoping that ICM is going to happen normally. Okay, and we have also at the occasion of WM Square, we have made a film. So this film is called Journeys of Women in Mathematics, and you can reach it easily also from the CWM website. And there was mainly interviews by 4 women, and including Professor Neela Nataraj from India. So I think it's really a great movie. And I would like to invite all the participants here to participate to the new WM Square and new ICM in 2022. I want to inform you that there is an extended deadline for application for the Cebichev grants. These are targeted for developing countries. It's now extended to 31 of May 2021, and it's important to apply before that date because The applications received before these dates are going to be given priority. And you have also an option to mention your interest in WM square when registering. And all this can be found on ICM 2022 website. So I really hope that many participants from India, and particularly for Indian women in mathematics, are going to be with us at the occasion of WM Square 2022 in St. Petersburg. So I really want to thank you very much for the opportunity for me to express myself and for this wonderful invitation to your closing ceremony. Many, many thanks. Thank you.
To you. Thanks to you.
I should stop sharing, right? Yes. Okay.
Thank you, Professor Roy. The annual IWM conference 2020-21 has come to an end. Despite the adversity due to the pandemic, I'm glad to see such an interactive, informative, and motivating conference where the audience also took part, and it takes place in a virtual mode. And this was possible due to the cooperation of several persons and bodies. I would like to extend my vote of thanks towards all of them in my closing remarks. First of all, I would like to thank to our guest of honor, Professor M.F. Roy, for accepting our invitation, launching the logo, and give such an informative talk about women mathematicians of all over the world. A very special thanks to our chief guest, Professor Seshu, director of IIT Dharwad, who honored this function with his inspirational thoughts during the inaugural ceremony. I thank the sponsors of our conference, NBHM, CWM, and IIT Dharwad, for funding and supporting the conference. I thank the speakers, the delegates, the panelists in the breakout session, and the invitees for being part of this conference and making it a successful one. I thank the session chairs as well. I thank the scientific committee of this conference as well as a whole IWM for taking care of the scientific activities of the conference, the organizers of this conference for taking care of logistics issues. I would also like to thank the volunteers for their help, our technical assistants for taking care of the technical issues of the conference. And last but not the least, I would like to thank all the participants of this conference, without whom this conference would not be possible. I apologize if I have missed anyone from my thank you list. Finally, I sign off by announcing the official closure of this conference with the hope of hosting you at IIT Dharwad in an offline version next time. Thank you all. Take care. This is Shagnik from IIT Dharwad.
Thank you, Sagnik, for the vote of thanks. And we would also like to thank you very much. You were our contact point in IIT Dharwad for everything. I think we have bombarded you with lots of mails, lots of requests over the months. And
it was worth it. The outcome is such a nice thing.
You have coordinated a wonderful job, a wonderful organization of this conference. Of course, you have a team behind you, and I only know Sri Devi Masuti, and your director who gave a very nice talk yesterday. But we'll thank all of them on our behalf from IWM. And now,
can we have a photo session with everybody probably switching on their cameras?
And then we can also have some discussion on feedback of participant speakers, whatever, so after the photo session.
And if I can add one word, I'm really happy to see that Carolina Araujo, who's also the vice chair of our committee, is also with us today.
Yeah, she gave a wonderful talk yesterday in our conference. So,
but she's still with us in the closing ceremony.
Yeah, today she's there. Yeah, it's nice to see her.
Mari, can you switch on your video now?
Oh, sorry. Yes.
Sagnik, can you arrange for the photograph?
Yes, just give me a second.
Yeah. We request all to please switch on the cameras.
Hello, Dipendra.
Oh, nice to see you, Riddhi. Of course,
Yeah.
I've seen you since yesterday.
Yeah, okay.
To see,
You're,
no, of course,
I am your representative also.
I see
CDC.
Gila and so on, but I did not want to interrupt the flow of things.
Yes, we'll be taking screenshots. I'm sorry to interrupt. Please, every participant, please switch on your videos so that we can take screenshots.
Yes, sir, I have taken a few.
Okay.
Okay. Could you cover everyone, maybe in 3 or 4 screenshots? Vince, was it possible to cover everyone in a few screenshots?
Yeah, I think almost
okay.
75.
Okay. Okay. Thank you. Thanks a lot. Thanks.
Right away putting in the chat now.
Okay.
Thank you.
We will upload those in our website. Okay.
So
please carry on.
Yeah. So should we open the session for discussion? People may have questions for anybody.
It's an informal session.
Sure.
Actually, the conference is closed. So those who can want to watch the match can go ahead and watch the match.
Okay. So this, anybody has question for Mari, Carolina, or anybody else, or a general suggestion, feedback, whatever. The feedback forms will be distributed by email to participants, but here this is an open discussion session for anybody who wants to speak. So Dipendra, would you like to say something to suggestions?
No, I mean, I wish such a conference was held physically and people could meet and interact, and I think it's typically much more interesting for me to attend lectures and also meet people, because maybe I also know many people, and I have been missing meeting people.
Yeah, actually, this is the 5th conference that has taken place, but we could not meet last year, but finally then we held it online. All others have been offline conferences. So
it's being held every year, or every
yes, it's being held every year since 2016.
Yeah,
so actually, yeah,
full activity.
So,
I think,
and it's usually 3 days, and we have also additionally some panel discussions and paper presentations by paper and poster presentation by young students.
Yeah, certainly.
And also there is in all conferences we have one workshop, like what do you call the mini course, so that every part, because this is a general conference and we have general participation of all maths masters and PhD and faculty. So we arrange a mini course, but this year it has not been possible because it's online, and we made it only for 2 days over weekend so that people can attend instead of 3 days.
And usually, I mean, sometimes the mini course is conducted by a male speaker. So otherwise, we try to keep our speakers as women in the IWM annual conference. So
it should certainly be an opportunity for them to present their works and so on. So it's certainly a good idea to restrict to mostly to women. Yeah.
Yeah, but I think there should be a day when this is not necessary. This is what I feel. So, but that's a far away in future, right?
Yeah. Right.
Yeah, I think people don't think, I mean, it's kind of stereotypes. People have to, if they look, they will find equally good women mathematicians also to give talks and present in conferences and all. But unfortunately, I mean, we all are very stereotyped, so even including women. So I feel that, you know, so this way it is helping other women, young women mathematicians to see all how women become successful in doing research and teaching in mathematics. Though we are not part of CDC, right? India is not part of CDC, right? We are kind of already developed mathematically.
What is CVC?
CDC, you are this.
CDC. No, India is very much part of CDC. You know, CDC has 5 categories of developing countries, and India is not at the rock bottom, but it is the next one.
Oh, okay.
So, you know, we are in fact at the bottom of the developing countries.
Oh, I see. Okay. So we have to do something about it.
Somehow,
if I can say something, I would like you to confirm that the Chebyshev grants are indeed open to Indian people.
Yes. In fact, I was wondering, Riddhi, can I send this advertisement about Chebyshev and Kowalski grants, which are, I think, being very generously being supported. But, you know, yesterday I had some email also, but, you know, I did not feel that I should.
No, we have already done a lot of publicity. Professor Marie-Françoise Roy has sent us, and we have done that. And many people have applied, I believe. So, yeah, so we are part of the Southeast Asian, Asia Pacific region. So, India is part of Southeast Asia Pacific region in Chebyshev grant. You can apply through
2 grants. One is Chebyshev and one is Kowalski.
Kowalski
is only for developing countries.
Sorry?
Kovalevskaya is for, developed countries. And so there the understanding is that the country supports substantial part of.
Okay.
So the Chebyshev grants are the relevant things for India.
But it didn't say that it is restricted to developed countries on the website.
Actually, if you look at Kovalevskaya grants, it does say developed countries. At least last time I checked, Because I think the understanding is that the society of the relevant country comes up with more than matching funds, or at least matching funds. In fact, I remember seeing developed in the phrasing. You can check.
I will check.
Yeah.
I think the definition of developing countries is not by mathematical level. It's really by income. I mean, per capita income. That's the definition of developing countries.
Yeah.
So it's really more related to the possibility for the countries to support trips to outside. It doesn't say anything about the intellectual level of the country, because of course, I think India is a highly developed country also in mathematical terms.
I think the Kovalevskaya grant, it says early career researchers. It doesn't say developed.
Yes, it's early career researchers, and also the country must provide the money for the trip. So it's only, the Congress is only going to support the local expenses, but there is a need for some national contribution for the trip.
Yeah, people have project grants and all, they can apply probably if they want.
Sorry, you want whose contact number? Lakshmikant, is it?
So, does any of you have feedback about our conference? Questions, suggestions? We are open to that.
Yes, absolutely.
I think there are a lot of them in the chat. I can have a look, and yeah, some people want to know grant details. So I will send to Sagnik, and Sagnik can share to all the participants. So
I think they have also recently extended the last date.
yeah, to 31st May, right?
Something like that. I
Yeah,
think.
Marie-Françoise
31
mentioned.
May, that the information I just mentioned in my slide. So,
Yeah, so a lot of people have been asking me because they don't have passport yet and then they can't register. So maybe it will help. This extension will help. You need passport to register. So.
These days, from what one understands, the passport process has been simplified.
Yeah, that is true.
So I think if people try it, it can come through within a month.
Hmm.
I thought maybe this might be a good time to. We had two breakout sessions where we discussed the impact that COVID-19 has had on teaching and research and career progression, and they turned out to be quite informative. We ended up getting, things that I think some of us had not thought of also came up in that. So Neela was asking me if I could summarize some of the main points of the breakout sessions, at least the things that surprised me.
yeah, and if I can ask also, please write a report and send it to Cwm, because then we can put it online also.
Mari, I've been very prompt in this. I've already done the report.
That's great. I don't even need to mention then. Sorry for that. Great.
We can
had,
do it immediately
the
also.
IWM report is not ready, but the breakout room report is ready. So, or at least it'll be ready by.
Thank you.
So yeah, so I mean, what was interesting in the discussion is, of course, all the troubles that is related to doing teaching online for teachers as well as students was definitely discussed. And I think one of the points that came up time and again was that in a country like India, when you are reliant on online resources like internet connections or even devices, the gaps between haves and have-nots only gets exacerbated. It becomes even tougher for students from lower economic backgrounds to have any kind of normal access to what's available online. So that was one issue that did come up, and and interestingly enough, I think what was emphasized was that somehow our educational institutions, as even government institutions, have not proactively tried to provide some economic schemes to help students to, either get internet package or devices of some sorts. It's been left to individual teachers and to help with these things rather than as a institutional kind of mechanism. So this was the another issue which came up is that women students particularly find going to college and university spaces giving them a sense of freedom and independence, which seems to have gone now that they have to study from home. So the physical infrastructure and the space that institutions offer for a free exchange of ideas and interaction are particularly important for women students. This is the first opportunity that they often get to be away from home, whether it is just in the same city for a few hours or whether it is away from their hometown, and this opportunity is lost to them. One other issue which came up was how will the academic community regard students who are now graduating during this pandemic period, in terms of, how valid would they consider their degree or even the scores that they're getting in the assessments. Their learning experiences are not something that people are paying too much attention to. There's more emphasis on, we need to complete our syllabus, doing our online teaching, we need to complete our assessment. But how well have students actually managed to learn during this period has somehow got lost in this discourse. And soon they will have to take entrance exams, which are in an offline mode currently in India. And there they will get tested on what they have learned during this period. So they are, in a sense, facing a double whammy of, well, triple whammy, I would say, not being able to access things very well, not being able to have the kind of peer level interaction or interaction with the teachers, and therefore their learning experiences have gone down a lot. And then they will have to, of course, sit offline competitive examinations where their knowledge is going to be tested. So the gap that between students who have good access to internet or good access to devices and maybe better learning experiences is therefore going to show up in admissions that happen to higher programs and to scholarships and so on. So this is something that, and another issue was that women students often, if they don't even, I mean, when it comes to if there are too many people in the house and too few devices or resources, or there is work that they have to do at home, they end up sharing the larger part of these burdens. So these were some of the things that came up in the discussions. And yeah, so I mean, people can add more if they feel I've left out something.
I think lack of books was another thing mentioned, because they, whatever, see, most of them have only cell phone and some of them don't even have their own cell phone. And not only they have to attend on all classes online and follow on a small screen, but they also have to read material online on that small cell phone, and it gets too much for them. If they had access to books, that would help, but it is not being possible because they are not allowed back in the university. Some places have allowed, but most places have not yet allowed students in because of the pandemic situation.
So I have one question. Do you think the situation was worse for female students, or it's universally the same problem for male and female students? I mean, these difficulties for being connected and so on. So that's my first question. And the second question is, so IWM did this study, if I understand well, or organized this session. Are there other bodies who are doing the same in India, which are not only IWM, but maybe other math societies in India?
I have one thing to say, that many of my female students said that at home, if there is work like looking after grandparents or cooking or cleaning, it's more the women, the girl students who are asked rather than their brothers. So it becomes, they keep saying that's why we are not able to devote time to studying. This was complained by many girl students. And the second thing is that DFOT, there is a forum which every weekend they meet around 3 o'clock, and then different people talk about pandemic related issues, and there are solutions given, and it's online forum and people can easily join and And it has been very informative.
From which organization, sorry?
It is just done by a group of academicians, not exactly any organization, but they're bringing out a book, and it would be online on Indian Academy website, Confluence. There is a part of Indian Academy online initiative called Confluence. They have essays, and so they are bringing out a book. I think it's already out. They have put all their discussions together, and it's freely available online. So I could share that, but right now I don't have. I have to search for it, and maybe I can share it. Yeah.
To add to what Riddhi said. So this is Srimay. I would just like to add to what Riddhi said about the girls having a tough time. I also know that in certain situations, like when there are disruptions in the internet connection, or maybe there's a poor connection at home, and the students have to move to a certain location to get a better connection, that is where the girls also have a lot of hurdles. So the male students tend to be able to find some place to go, and some internet cafe or somewhere where they can access the study material or see the lecture videos. We know for a fact that a number of girls who are studying in our institution wrote to those in the administration saying that the recent internet shutdowns in certain parts of the country made it very tough for them, because their male classmates were able to access the internet by going out to some other place, but the situation was not conducive, or maybe even their family was not willing to allow them to do the same, and they were losing out on that part as well. So this was an additional problem.
Thank you.
Mari, there is a request from the participants if you and Carolina would share as to what is happening in your countries to match education under COVID-19. And is there a problem which is gender-based there too?
Okay, maybe Carolina, you can say something.
Well, I can say something about Brazil. So when I heard Gita your description of the situation in India, it reminded me, it made me feel a lot like it's the same. It's very similar to what's been happening in Brazil. We see the gap between the haves and not haves increasing, and this is a very serious situation, and I'm afraid that it will take decades so that we can actually go back to the size of the gap before the pandemic. So I think that we've been facing similar situations here, and also I feel that there is a big difference between male and female because of the care. So usually when there is someone sick in the family, the women are those that actually care for the family members, and also for mothers. So mothers, both students and researchers and academics in general, mothers of especially of young children are feeling it harder than others.
Yeah, so I can say something also about France. So first thing I want to say that in general, it is well known that women scientists have been suffering from the COVID crisis much more than male scientists on an international basis, exactly because of the reason that were mentioned, that women had more responsibility with children care, elder care, and so on. So that's something really international. What I can say about France is that first, for the students which are not from, say, wealthy family, they have little jobs, I mean, that make them possible for them to complement their income so that they can study. And this stops nearly entirely because all these jobs disappeared. And so that was a big problem. And now we see a lot of students who are now part of this humanitarian help. I mean, they need to go to get food because they don't have enough money to get their own food. So it's really a big social problem now. I must say, I think it's kind of similar for boys and girls, for students. And also there are a lot of psychological consequences, also the difficulty to go out, to study, to see people, to be always obliged to study online, and then also some worry about how their diploma is going to be considered later. And also if they are going to find work when the situation is coming back to normal. So there is a lot of anxiety, and the government was really not taking care of that for many months. But recently they've been really understanding that there is a big problem. And now they provided a very cheap meal for students, which is €1 meal, high quality. And then I see that it's really helping some people, even in my own family. I mean, it's making a difference. So even in countries which are considered as developed, as France, in every possible meaning of the word, it has been a very tough moment for women in science because of all the responsibility in the family, and for students in general. And I think it's more or less everywhere in the world.
So let me mention this, that many of the universities and institutions use funds from alumni donations to help the students to get, say, internet pack or a device. Or this is done by many places. University of Hyderabad has done it. I think Ambedkar University may have done something. Some of the IITs have done it, and ISERs have done it. But unfortunately, my university did not do. And in fact, last 1 year, even our subscription to MathSciNet has been stopped, saying there is no money. So, I mean, it's going other way around.
Anyone else like to say something?
Yeah, we would like to hear from some students. I have not heard much from students. Can they speak? Some students should speak.
I think one of the participants wants to ask about Fields Medal, Lakshmi Lavanya Ramamurthy.
Yes, ma'am.
Hi.
Good afternoon, good evening, everyone. So it's a general question, like usually the age limit is there, but this time, as Professor Carolina was also mentioning, like everyone is affected, and especially women with young children. So would there be any possibility of extending the age, at least for the upcoming Fields Medal? I don't know, maybe it's a too much question to ask. I'm so sorry. Please forgive me if it's offending anyone, or like I'm nowhere near that to even ask that question. It's for the benefit of others, I should say. Like I'm not at all in that league. Yeah.
It's an important question. So in fact, it was already discussed by IMU, and at this point, they decided not to change the rule. So independent of how many children you got, they are not going to extend the age for the Fields Medal right now. They decided not to.
Okay.
And in fact, it was a little even, I was not too happy about that, because I heard that they had this discussion. CWM was already existing, but when they had the discussion, they didn't include at all CWM. They didn't ask what we feel, and they didn't consult us. So that was not very nice. So we were not happy with that. We mentioned it. And now we have some global recommendations from the Gender Gap in Science project that we should really take into account, you know, when someone had, when a young woman had children, that it should be taken into account in the age limits for all the grants and for all the awards and so on. So that's what we as CWM are asking. But right now, IMU is not doing it. So maybe something that we can be rediscussed in the future. But so, of course, I mean, sometimes it's the father who's also very much in charge of the child. So it should be taken into account also in that case. But basically right now, they didn't change the rule.
Thank you, ma'am. Thank you so much.
Many grants have some extra year given to women, like, you know, 2 years added to their, I mean, you count, say, a 30-year-old woman at par with 28-year male or something like Humboldt Foundation does that. But in general, yeah, it is not true.
Yes,
and yeah,
I think more and more institutions do it for grants, for awards and so on, but it's not yet everywhere, and certainly not for the Fields Medal.
So we also have Professor Donna Strauss from UK. Maybe she could say something about situation in UK. Donna, welcome here. Yeah.
Hello, I'm watching from Brighton on the south coast of England, where it's a cool spring morning.
Hello, Donna. Do you have something to say about women in mathematics, pandemic effect, or whatever you would like to say?
Well, I'm sorry, I wasn't able to connect to the conference before now, and so but I think this is a really impressive gathering. I feel very impressed, and I thank you for inviting me to take part.
Oh, thank you, Donna. So Donna and I regularly, and Ajit Iqbal Singh and many others, attend these Hawaii seminar on topological groups. So we are in the same group there. This takes place at 6 a.m. in Hawaii, 6 p.m. in France and Germany, and 9:30 in India. So 9:30 p.m. in India. So it covers a large number of people. And sometimes people from Australia are also there. For them, it's, I think, 2 a.m. in the morning. Donna, do you know anything about the effect of pandemic in mathematics in UK? If you want to say something.
No, I'm sorry.
Yeah, no problem. It's just, I thought you might want to share something, but it's okay.
Yes.
Yeah. So
I've been out of touch for quite a while.
Yeah.
Because apart from being retired,
yeah,
my husband and I have been self-isolating for a year because of the virus. So I don't really feel in touch.
Donna also visited India and gave talks in Delhi University, and in Jammu also she gave talks in Indian Math Society annual meeting.
I visited India the year before last, and that was a wonderful visit. It was a wonderful experience. The first time I had ever been to India, and I had the pleasure of meeting Reddy then. And I've had the pleasure of meeting Ajit. He's my mathematical sister because we had the same supervisor. I've had the pleasure of meeting her both in England and in India. Hello, Ajit. Lovely to see you.
Me too. And Sardar Patel University conference brought Donna and others to India. And Sardar Patel University in Gujarat brought Donna and others here. And we thank them for that. And thank you, my elder sister. I have always looked up to you as a role model. Donna, I mean.
It's lovely to see
you.
Does anybody else have anything to say? Then we can. Any suggestions, feedback, any questions, comments? Ha, Padmavati, go ahead.
This is something that I wanted to say to Professor M.F. Roy. Hello, Professor M.F. Roy. I am Padmavati from University of Hyderabad. I wanted to know if there could be a possibility of this kind of a online session in the WM Square for women who cannot travel and come.
It's a very interesting suggestion. I don't know the answer, but we are going to think of it, yes.
Like
yes.
Many people are saying because
no,
of...
it's true, I mean, yes.
Or,
yeah.
So I don't know, I mean, maybe it will be something general also that ICM in St. Petersburg is going to want to organize, not only for WM Square, but for the whole event ICM, but I think it's very relevant. So I think it's a very good suggestion. And we are, I mean, I see that Carolina is also approving. So indeed, it would be really a way to have more people, maybe not for the whole day, but at least one session, for example. It could be really a way to include people who are not going to be able to travel to
I think you could
Russia.
do whole day because some people in some parts of world will attend some session and others in other session. Perhaps
I don't know. I mean, all day, maybe it's a little complicated because, you know, there are some moments where we do very decentralized discussion in little groups. So I don't think
those not.
I don't think we could do it
talks.
for the whole event, but probably we could do it at least for, I would say at least for one session and probably more. I think we need to think of it. And we are going to, I really thank you for the suggestion. It's a very, very interesting suggestion. Thank you.
Goes well, maybe you can plan it for a little longer in the next time.
So in fact, I mean, this is something I guess once we are hopefully out of the pandemic, I think some of the positives that have happened, which is being able to access, you know, lectures and mathematicians from across the world through these online mechanisms, I hope we don't lose that. It's still far better to be there physically, but for those who are just not able to travel for one reason or the other, it would be nice to have a kind of hybrid mode in all the conferences in the future. I think it would help women particularly quite a lot, I think. So
yeah, I agree. And in fact, I can even tell you something we are doing right now with CWM. We wanted to have a meeting of CWM ambassadors in Tunisia, and that was not possible. So finally, we are now having virtual meetings of all the CWM ambassadors. So we had the first one in Europe last week. We're going to have some in Africa. We're going to have also some in Asia. So it will be for CWM ambassadors only because we want to restrict it to a specific network. But in fact, it is really helping because more people are going to meet this way and to interact. While if we were organizing a physical meeting in Tunisia, probably not so many people would be able to come. So I agree that there are some advantages in this big disaster, which is COVID. Some things are quite positive. In fact, I agree with you. And maybe, and especially for women, because maybe they would not be able to free themselves for the whole week, for example, but maybe they will find a few hours to participate to the event. So that's also a good thing.
So I have something to add here. This is Srimai from IIT Guwahati. So I have an apprehension in this context, and that is that when the things are starting to open up and we start having physical meetings, it might so happen that will create a new set of haves and have-nots in terms of being able to travel. I mean, it may affect both genders, but women more maybe because of the various restrictions that might be at play, which might require having to travel in more difficult circumstances. And right now, I can say from my personal experience that upcoming September in Italy, they're trying to organize, a very small group is trying to organize a meeting, which is actually right in the topic of my research interest. And some of the people who are speaking there, I have worked with them, but they have made this only physical conference. I already wrote once to them to consider making it in a hybrid mode, but they have expressed their difficulty that the place where they are trying to hold this meeting, which is in a small hotel somewhere in the coast of Italy, might not have the resources to do that. And I was really looking forward to listening to those talks because it is exactly in the area that I work on. But I'm afraid I don't see any possibility for me or any of my students, be it male or female, to actually go there and be there. Although they themselves are not quite certain they will be able to hold this physically in September, but they are hopeful, and I have almost no hope of that. So let's see how it works out. But I think I have this feeling that things might be a little uneven for us in the times ahead.
So are there any more suggestions, comments? Otherwise, we would reluctantly like to say goodbye to everybody. It has been a wonderful 2 days of communicating with all my old friends, new friends, and enjoying mathematics. It really makes me excited and inspired to start thinking of new problems and new mathematics that I want to do. So anybody wants to say something?
I want to just say one line that since Marie-Françoise and Carolina are here, would like to tell that all the EC members are extremely active and supportive, and they manage the entire activities of IWM. So I would want to give a big round of applause for the EC members of IWM. Thank you.
Neela is just being modest, you know. She does much more work than
the Major General.
Yeah, right. So, thank you, Neela, for doing this with all your other responsibilities and academics. It's really nice that you have taken over and are doing such a wonderful job. I don't think logo would have been possible without you and without everybody on IWM, of course, but the initiative is important.
We also have Riddhi driving everybody.
Everybody nuts.
If we don't, do something, apart from Neela, there's also Riddhi reminding us. So there's no choice.
Okay, so thank you, Marie-Françoise Roy, for being our guest of honor and inspiring and encouraging us over the years. And thank you for releasing our logo. And we are really happy that you were with us, sharing your thoughts and ideas. Thanks to Carolina also, who gave a wonderful talk and had interaction yesterday and today. And thanks to all our participants and organizers in IIT Dharwad and all the speakers. I think I'm repeating vote of thanks again, but thanks all my friends, and I've had a wonderful time for last 2 days. And I hope all of you will take something positive and remember this and have a cherished memory of this conference, and it would inspire you to do more mathematics. Thank you.
Okay.
Bye.
Thank you.
Bye. Bye.
Good job, Riddhi.
Not me. It's everybody, right? Bye, Donna. Bye, Ajit.
Goodbye. Goodbye.
Bye.
Bye to all. Bye.
I'd like to say how wonderful it is to see so many active women mathematicians. When I was young, it was very rare for a woman to be a mathematician. I remember being at large conferences, maybe more than 50 years ago, like a meeting of the British Mathematical Colloquium with more than 300 participants, where I was the only woman.
Yeah, that is true. Sometimes it happens, no? Even now, sometimes it does happen, I believe. So.
Can I say what I wrote in chat?
Yeah, sure. Go ahead.
Your wonderful conference, which is so exhilarating and which will have a long effect, proved yet once again that there is no difference between a man mathematician and a woman mathematician. This conference is a proof.
Yeah.
You can do anything just as well or even better. All the best.
Yeah. Bye. All the best.
Goodbye.
Bye. Thank you, Ajit.
Bye.
Bye.
Bye.